All right, comparing and ordering rational numbers. All right, let's try a sample problem. Today I went fishing and it rained. Every 9 days I go fishing and every 12 days it rains. When will it rain again on the day I am fishing? I'm going to map out the multiples of each of those numbers, the 9 and the 12. So every 9 days I go fishing, so 9, next number is 18, add 9 to that, I get 27, 36, 45, and I'll stop there. And then I'm going to map out all the days for when it rains. Well, there's every 12 days it rains, so there's 12. Add 12 more and I get 24, and then 36, and then 48. But oh wait, I got a match. So that's the first one they had in common. So this is called a least common multiple. So on the 36th day, it's going to rain when I'm fishing. And hopefully I'll catch a big one that day, right? Because we all know the fish bite a little better when it rains, right? Now, multiples are when a number is multiplied by a natural number. And if you'll recall, natural numbers are numbers that are the counting numbers. What do we start counting with? 1, 2, 3, etc. So in other words, 0 is not a natural number, so we wouldn't say 9 times 0 and say the first multiple of 9 is 0. We would say 9 times 1 gives us 9, 9 times 2 gives us 18, 9 times 3 is 27, etc. And the LCM is the least common multiple, and that's what we just found. That was the first multiple that 9 and 12 had in common, which we got to be 36. So for smaller numbers like 9 and 12, that's probably the easiest way, is just to list out the multiples, circle the one they have in common. But there's a better way to do it for bigger numbers. Now, 2 and 4 are not the bigger numbers I'm talking about. Those are teeny tiny numbers. We want to use prime factorization to find the least common multiple when we use big numbers. And we're going to follow 3 steps to do that. And that first step is going to be to line up the prime factors from least to greatest. And then we want to, for step 2, record the greatest power of each factor. Now, if you'll recall, when we were doing greatest common factor, we looked for the one they both had in common. But here we're taking the greatest power for each factor. So they're backwards of each other. And then our last step, our third step, is to multiply. And we want to check it. We want to ask ourselves, does this make sense? All right, let's try 2 large numbers, not 2 and 4. We know their least common multiple is 4. But this time we're going to pick numbers like 84 and 120. So find the LCM of 84 and 120. I'm going to look at my steps. I want to do the prime factorization for 84. So I'm going to do my factor tree. And I know that's even, so I might pick 2 and 42. I'm going to underline the prime numbers. So if prime, underline 2 is prime. 7 and 6. And I know 7 is prime. 6 can be broken down into 2 and 3. And 2 is prime and 3 is prime. All right, I'm going to do the same thing for 120. This one ends in 0, so I know 10 will go into it. And it's 10 times 12. Then I can break the 10 down into 2 and 5. And they're both prime, so I'm going to underline them. And then 12, I could do either 2 and 6 or 3 and 4. I'm going to do 3 and 4. 3 is prime, and then 4 gives me 2 and 2. And they're both prime. So I've completed step 1 as soon as I line them up. And then step 2 is record the greatest power of each of these factors. So let's check that out. I have, for 84, I have 2 squared times 3 times 7. And I'm being smart as I go. 2 squared is 4, 4 times 3 is 12, 12 times 7 is 84. I'm just making sure it matches that number. All right, and I'm going to do the same thing for 120. I have 2 to the, let's count them, 1, 2, 3, 2 to the third power, and then times 3 times 5, and I'm going to check that one to make sure it makes sense. So 2 to the third power is 8. I'm going to do commutative property here and switch these around. So 8 times 5 gives me 40. 40 times 3 gives me 120. So I know I did that right. Now on that second step, the greatest power, look at 2 squared and 2 to the third. 2 to the third is the greatest power out of the 2's. So I write 2 to the third down. And then I'm going to look at the 3's. The greatest power for 3 is 3 to the first. And then for 5, I know they both don't have a 5, but it doesn't matter. You're just looking for the greatest power for each factor. So one of them has a 5, so I write that 5 down. That's 5 to the first. And then one of them has a 7, so I write the 7 down. And it has 1 7, so it's 7 to the first. And now that last step, that third step, was to multiply. And if I multiply those out, I'm going to try to be smart about this. 2 to the third is 8. And then I think I'd rather do 3 times 5 next and get 15, because I know that 15 times 8 gives me 80 plus 40, 120. And then I can do 120 times 7 mentally, because I know 7 times 12 is 84, and I know I'm just tacking on a 0. So it would be 840 is our LCM. So again, it's just as simple as lining up the prime factors from least to greatest, recording the greatest power of each factor, and even if only one of them has a 5 or only one of them has a 3, you still write that number down, and then you multiply it, and then check it to make sure it makes sense. So I know the multiples of 120 are like 240, 360, and I know they're not going to match up with 84 for a while, so that's a really big number. It makes sense to me that it's 840, because I can't think of a small number that would match up. All right, let's take the LCM of variable expressions. And this is not that different. We're just adding a couple letters in there. So we're finding the LCM of 9x to the third, or cubed, and 15x squared y. I'm going to do the same thing. I'm going to do my factor tree. So 9x cubed, and 9 gives me 3 and 3, and they're prime, and x to the third gives me x times x times x. Now those are broken down all the way, so I underline them. And then for 15x squared y, I have 3 and 5 for 15. And then x and x. And then just the y. So now I'm going to line them up. So I have 3 squared x cubed for the 9x cubed, and then for the 15x squared y, I have 3 times 5 times x squared times y. Now take your time on this. You're wanting to circle the greatest power for each factor. So for the 3, the greatest one is to the second power. So 3 squared. For the 5, the greatest one is just to the first power. So just 5. For the x, the greatest power is to the third power. So x to the third. And then for the y, the greatest power is just y to the first. Now I'm going to simplify that all out. So 3 squared is 9. 9 times 5 is 45. X to the third, or x cubed, y. Now I'm going to ask, does that make sense? I'm going to look back up at the initial question. And 9 and 15, I can think out 15, 30, 45. Yeah, 9 goes into 45. So that makes sense. And then my greatest x is x to the third, so that makes sense. And my greatest y is just y. So always check it to see if it makes sense. All right, the last topic we're going to talk about is comparing fractions. And there are 3 ways to do that, and I'm going to show you all 3 because sometimes it's easier to do it one way and sometimes it's easier to do it another way. The first way is we can make equivalent fractions and just compare the numerators. And what I mean by that is get the same denominator. All right, the next way is we can divide and just compare the decimals. And then the last way is we can do a method called bottom-top drop, where you just compare the product of the diagonals. All right, we're going to do one example, and we're going to do it all 3 ways. And our example is going to be compare -3/4 and -5/7. So we're going to do it the first way using the first method. We're just going to make equivalent fractions. So the 4 and the 7, we're going to get the same denominator. I'm just going to spread these out when I write them. So -3/4, I'm going to give myself a lot of space, and then write -5/7. And the 4 and the 7, think about the multiples for 4 and 7. The least common multiple. I can list them out. 4 and 7, I'd have 8, 12, 16, 20, 24, and then 28. And 7 won't go into any of those until I get up to 28. So 7, 14, 21, 28. And that's a trick. If you know nothing will go in there, you can always just multiply these 2 numbers. 4 times 7 gives you 28. So now we have a common denominator. So 28 and 28. And now ask yourself, how do you get from 4 to 28? Multiply by 7. How do you get from negative? You do -3 times 7. And we get -21 on top. Do the same thing over here. 7 times 4 gives me 28, so I multiply by 4 to the -5. and I get negative 20. Now that I have the same denominator, it's like it's out of the same number of pieces of pizza, so you just compare the numerators. Although I would hate to have negative 20 pieces of pizza. Number one, that's not possible, and number two, that's no fun. So negative 20 and negative 21, which number is greater? Well, I know that the lesser negative is the greater number. So it goes like this. So the alligator is eating up the negative 20. So the lesser negative is the greater number. And I don't just have to memorize that. I can just look at a number line. I know on a number line that the more positive numbers are to the right, the more negative numbers are to the left, and the greater numbers are more positive. So, for instance, negative 1 is greater than negative 2 because it's further right on the number line. All right, now that we have method A down, let's try method B. We want to divide and compare the decimals. So let's do 3 divided by 4. Notice I say it forwards, write it backwards. 4 won't go into 3, but it will go into 30. 7 times, I get 28. I bring down a 0, and 4 will go into 25 times. Now don't forget, that's a negative 0.75 because it was negative 3/4. So I have negative 0.75. And then for the other one, negative 5 divided by 7, I just do 5 divided by 7. 7 won't go into 5, but it will go into 50 7 times. I get 49. Bring down a 0. 7 will go into 10 once. And then subtract, bring down another 0. And honestly, I can stop there because I'm looking at these two numbers. I don't need to keep going with this. I'm comparing negative 0.75 and negative 0.71. And remember, the greater negative is a lesser number, and the lesser negative is the greater number. So just think of that number line. So really, this one's going to be the greater number, or negative 5/7. Because negative 0.7, I think 71 is less than 75, which means it's closer to 0 on the number line. All right, our last method is bottom, top, drop. And again, we should be getting the same method, or the same answers for all these. So that was method B. Now we're on method C. And a lot of people like bottom, top, drop just because it's normally pretty quick and easy. So negative 3/4 and negative 5/7. All you do is bottom number times the diagonal top number and then drop it down. So think 4 times negative 5 is negative 20. And now think 7 times negative 3 and then drop it down is negative 21. And now just look at negative 20 and negative 21. Which one is more positive? The negative 20, so it's the greater number. So all three ways work. Sometimes you want to use bottom, top, drop. Sometimes you want to get the same denominator. And sometimes you might want to make them into a decimal. So you get to pick. So when it comes to comparing fractions, it's your choice.